Yeah, it's because I'm like in the mountains right now, because I'm in Puerto Rico. So
Uh-huh.
yeah.
Oh, so you're running your, the internet is not working so great.
Yeah.
We'll have to talk about what to do when it comes to the test, if that happens.
It's fine. I'm getting home now, so it's okay.
Okay, I think we should get started. I hope you see there's a problem on the board to do, two problems. Um, just wanted to announce, I thought that it makes the most sense for the midterm to be the Friday right before spring break. It's a, and it's supposed to be during class time, so I'm setting it up that it'll be available starting at 10 o'clock, and it'll be available till, I probably will make it available till 12 or 1, even though it's supposed to be over by class. Again, it's similar to what we do on Delta Math, and also if any of you tried that test that I gave you on Blackboard, once you start the test, you have to complete it in one sitting. You will be given probably an hour and a quarter. I'm not remember. I think for the midterm they give an hour and a quarter. But it has to be done on that date. If you're not available for that date, you're going to have to let me know so I can set you up as an exception for when the test will be available for you. Again, so a week from Friday, it's not this Friday, a week from Friday, and you don't sign into Zoom, you sign into Blackboard and take your midterm on Blackboard. I will be giving you another quiz. It'll probably be optional, though what we usually do is when I give a bunch of quizzes at the end of and tests at the end of the term, if you've taken them all, I just drop the lowest marks. So you're better off taking all the things that doing all the assignments you possibly can, and certainly doing all the midterm, all the tests. Again, the midterm and final are from the department and they are mandatory. Does anybody want more time to do these two problems? Anybody need some more time? Okay, if not, let's do the first one. Does somebody want to tell me what to do the first one? Anybody volunteering? Oh, come on.
I will.
Okay, Cheryl, great. Okay, what did you do with this one?
I find the AC first.
Okay, what was the AC equal to?
8, negative 8 and plus 6. I don't know if.
Okay, the AC turns out to be negative 48.
Yeah, negative 48, yes.
You didn't mention it because it's already there.
Yes.
It says solve. It's a quadratic equation because it has an x squared, and therefore you have to get it equal to 0. And she didn't have to say all that because it was already there. So she's trying to factor this by finding the AC. And what numbers did you pick?
8 and 6, negative 8 and positive
8 and 6.
Yes.
Well, let's just talk about 8 and 6 because 8 times 6 gives you 48.
Yes.
And since this is negative, one has to be positive and one has to be negative. The middle one being positive means the 8 is the positive and the 6 is the negative, right?
Okay, yes.
Okay, and you put
So
X,
we bring down the x.
okay.
We bring down the x squared.
Okay, so we have all this. So now what did you do?
Yes, so we're gonna factor, bring down x. We're going brackets, put another x plus an 8
Good.
bracket. So we bring down the minus 6,
Right, negative 6 is your
x
contact.
bracket x plus 8
Right.
bracket, yes. So we have x plus 8 and x minus 6
Okay, and this all equals
equals 0. Yes.
Right. And by putting the equals 0, but now we need it, okay?
Yes. So x plus 8 equals 0.
Okay, so I'm gonna go over here because I'm running into space. X plus 8 equals 0.
0 and x minus 6 equals 0.
Okay.
So 8 minus 0 or okay,
Okay,
equal minus 8, yes.
so one answer is X equals negative 8.
8 and 0 from that leave negative 6.
Perfect.
Yes.
So she got the two answers. So this is a standard quadratic equation. It's called a quadratic equation. It has an X squared. We know that we factored it, set each factor equal to 0 separately, and solved each of those. So you get as your final answer negative 8 and 6. You could write x equals negative 8 and x equals 6. You could just write negative 8 comma 6 also. If you don't want to have to write the whole thing out, all you have to do is write, it's not an inequality. You don't have to put a greater than or less than, it's equal. So you could just write the answers. Sometimes they put the answers in brackets also, braces, I don't know what they're called. But you got these two answers, negative 8 and 6. Not just a matter of factoring, it's factoring and finding the solution. Does anybody have any question about how to do this? Okay, so let's look at the next one, where we have 3x squared equals 27x. Now, this one I'm going to want to do because it's a little bit different. I look at it, I see it's a quadratic equation because it has an x squared. If it's a quadratic equation, then I want to get it equal to 0. So I'm going to bring this 27x to the other side. So that my equation becomes 3x squared minus 27x equals 0. So the determinant as to what makes something a quadratic equation is the fact that there's that exponent there. And once you see that, you really want to get it equal to 0. Then the next step is to try and factor. And the first type of factoring that I always look for, no matter what other kind of factoring I might have, I always check, is there a common factor? And there are only two terms here, and yes, there's a common factor of 3x. So I take out the 3x, and 3x into 3x squared gives me x, and 3x into negative 27x gives me negative 9. And now I have to set each of the factors equal to 0, just like we did over here. We separate. So my first factor is 3x. So I get 3x equal to 0. And when I divide by the 3, 0 divided by 3 gives me 0. So one answer is x equals 0. Then I do x minus 9 equal to 0. And I bring the 9 to the other side, and that gives me x equals 9. So that I get, again, my two answers, one answer being 0 and one answer being 9. Don't forget that it's a quadratic equation and you want to get two answers. Does anybody have any questions about this? Okay, so then let's go on further. First of all, I'm going to do something that's a little bit out of order. I think we need to mute everybody. Melissa, you want to mute everybody, and I want to mute, and then everybody can unmute themselves. Oh, okay. Guess it's not necessary. Okay, so I want to show you an alternate way to solve quadratic equations. I'm going to do it with this particular example, which I know we solved it and we got -8 and 6 as our answers. There is something called the quadratic formula. A formula is a set of letters that you can replace with numbers to figure something out. For example, we used the formula for the perimeter of the rectangle. We said the perimeter P equals 2W plus 2L. It gives us a specific way to figure out a problem. The quadratic formula is a formula that we can use to figure out the solution to a quadratic equation. Why would we need a formula? Well, number one, sometimes the factorings are very hard. And if you can't factor, that's the only method we right now have to solve this quadratic equation. Remember, it's very important to be able to solve the quadratic equation because solving equations is one of the main things we do in algebra. And once you have something with an exponent, you have to have a method to solve something with an exponent. So far, our only method involved is this factoring method. Well, what if you can't figure out how to factor something? Or what if something can't be factored? Does that mean we can't solve the quadratic equation? And the answer is no, because there is this formula that you have to memorize. It's not going to be on, the formula is not going to be on the midterm. All the quadratic equations that you will have on the midterm, you will be able to solve by factoring. But if you want to memorize the formula and use the formula, that's fine. Here's what the formula looks like. First of all, in a quadratic equation, the standard quadratic equation looks like this. Ax squared, something times x squared, plus bx, something times the x, plus c, plus some other number, equals 0. In other words, Once we see that we have a quadratic equation, we bring everything to one side and arrange the terms in what we call descending order, and it has to equal 0. The number in front of the x squared is called the a. Now, if I look at my example, what would the a be in that example? Anybody?
X
Put
squared.
on what is it?
X squared.
Okay, the a is not the x squared. The a is what is attached to the x squared.
1.
1, right. If there's no number in front of it, then the answer is 1. The b is the number that's in front of the x. What's the number in front of the x? 2. Notice if there wouldn't, let's say, be any x term, if it would have just been x squared minus 48, let's say, and there was no x term at all, then the b would have to be 0. In other words, if a term is missing, it really means it's being multiplied by 0. The c is the number that stands alone. What number is that in my example?
48.
Close. Is it 48?
Negative.
It's
Negative
negative.
48.
Let Miss Ortiz hear you. Hear us.
In other words, the sign of the number is part of it. So, and for every single quadratic equation, we could do this. We can figure out what the a is, we can figure out what the b is, we can figure out what the c. Now, once you've done it, then you can use the formula. Here's the formula. This is the formula. X equals negative b plus or minus the square root of b squared minus 4ac, all in the square root, over 2a. Now that's a very complicated formula, but it's so important for you to know that, as I said, it's not going to be part of the midterm. It's not going to be it's not going to be on a test until after we come back from spring break. But probably one of my quizzes will just be a quiz where you will have to write out the quadratic formula and then apply it, because it's very important for you to know this formula by heart. Now, how do we use the formula?
Professor, you put 49C and it's 48C.
That's an A.
Oh, that's an A. I'm sorry.
4AC.
That's a b squared.
Yes. Let me see if I can. I'm going to rewrite. Can you see up here? I'm going to write it over here because it's very important to have it because I want to have it on the board. It's negative b plus or minus. I'm going to have to explain all of these things to you. The square root of b squared minus 4ac, all under the square root, all over 2a. I'm going to leave this on the board here because we're going to do a few of them. Can you see it? Okay, so I'm going to erase it from here and fill it in. So I'm going to show you how to use this formula. First of all, I'm going to take, and I always do this when I'm using the quadratic formula. I write out the formula for myself. I don't try to work it with my head. I write out the formula. I know I have the formula memorized, but I write it out. And then I write out what the A, the B, and the C is for the particular problem that I'm working. And then I fit in the numbers. Wherever there's a letter, I'm going to put a parentheses, And in that parentheses, I'm going to put the number. In other words, the first thing I see is negative b. So here's my negative b. I put a parentheses and I put the number that is the b, which is a 2, in the parentheses. Then I do this plus over minus square root. And again, we have this parentheses b squared. Again, the b squared is 2 minus 4. And now we have two parentheses, one for an a and one for a c. And I'm going to put in those numbers. The a I know is 1. The c is negative 48.
This, this is way too dirty now. While it was still wet and it was in the sink, it ended up all in on the floor.
Look,
Mute yourselves.
Mute yourself,
Please
girl.
mute.
She talking. That's disrespectful.
Okay, thank you. And this is over 2a. So here again, 2, here's my parenthesis. Notice I just took the formula. In place of each letter, I put a parentheses. And in the parentheses, I filled in the number that is appropriate. For the B, I filled in 2. For the A, I filled in 1. For the C, I filled in negative 48. And I'm really almost home free. All I have to do now is simplify this. Okay, so let's do this. There's a negative in front of a parentheses 2, so that's obviously just a negative 2. I have plus minus. I'm going to tell you in a minute what that stands for, this symbol, because it's a little different than something we've ever done. But the important thing is to figure out all this thing that's inside the radical. So the first thing I see is 2 squared, and I know 2 squared equals 4. And then I have negative 4 times 1, which is negative 4. And negative 4 times negative 48. So I don't know by heart, so I'm going to do negative 4 times negative 48, which gives me 192, a positive 192. Because this was a negative times a negative. And 4 plus 192 gave me 196. And over 2 times 1, which is 2. Notice by figuring out what's inside this radical, it made the whole thing much easier. And the next thing I want to do is figure out what this radical is, what the square root of 196. Now you have on your calculator should have a square root button. If you don't know the square root of 196 by yourself, that's the point of your calculator. Go to the square root button and put in 196. And when I do that, I come out with 14. The square root of 196 is equal to the number 14. Little bit later in the term, we're going to learn what to do when this number is not what we call a perfect square. When you can't take its square root. But right now, all the questions that we're going to have, this number that's inside the square root is going to work out to be a number that has a square root. So when I replace that, what I get is negative 2 plus or minus 14 divided by 2. And now I want to talk about what this symbol stands for. This is a shorthand. The plus over the minus means really we're going to have to do 2 things. One time we're going to have to add the 2 numbers that I have there. And the second time I'm going to have to subtract. In other words, this really means, one, that negative 2 plus 14 over 2. In other words, use the plus with it. And the second one will be negative 2 minus the 14 divided by 2. In other words, instead of having to write this whole thing twice to get your 2 answers, they're almost the same thing, only in one place you're going to be adding, and in one place you're going to be subtracting. Now, if I work these out, the first one gives me negative 2 plus 14, which together gives me 12. And 12 divided by 2 is 6. The second answer, negative 2 minus 14, gives me negative 16. And negative 16 divided by 2 gives me negative 8, which is exactly the answers that we had gotten before, 6 and negative 8. Notice I didn't have to factor. If you don't like factoring, you don't have to when you have a quadratic equation. If it's a question that asks you to for factor, you have to factor. But if it's a question about a quadratic formula, a quadratic equation, you can use a quadratic formula. Again, I think usually the factoring method is easier, but this is another method. Any questions about it before I give you one to try? Any questions? Okay, so I'm going to put in another example. I'll get you started and then I'll take attendance and then we'll do it together.
Wait, Professor, don't erase it. Don't erase it.
Oh, you know, okay. Can I erase it yet?
Yeah, you can.
Okay.
I literally need like 30 seconds.
Corey, you still copying it?
Yes.
Okay, I'm not erasing it then. Until you give me the okay.
Okay.
Okay. So I'm leaving on the formula. And I'm going to give you another problem. I'll get you started and then we'll do it together. Let me see. Okay, here's my question. X squared plus 3x minus 10 equals 8. Okay. I'll just start you off on this. I see it's a quadratic equation because it has an x squared. I want to solve it using the formula, and I'd like everybody to try using the formula. You can then try doing it using the factoring method to see that you get the exact same answer. In order to use the formula or to factor, you first have to get it equal to 0. So you're going to have to bring this 8 to the other side. So your quadratic equation comes out to be x squared plus 3x minus 18 equals 0. Okay, here's what I want you to do. I want you to write down what the a, the b, and the c of this equation is, and see if you can use the formula to solve it. And while you're doing that, I'm going to be taking attendance. Azia?
Yes.
Good morning.
Good morning, Persephone.
Nashia?
Yeah, good morning.
Good morning. Annabelkis? Annabelkis, is she among us? Emma? Emma? Messiah? Messiah? April?
I'm present.
Good. Khadija?
I'm here.
Good. Umar?
Hello.
Hi, good morning.
Sebastian, how you doing?
I'm great. Yakima?
Good morning, Professor.
Good morning. Cheryl? Stacia?
Good morning, Professor.
Hi, how are you? Natalie?
Here.
Good morning. Erica?
Good morning, Professor.
Good morning. Jonathan?
I'm here.
Okay,
Good
great.
morning.
Luke? I know Luke's been here. I know I saw him. Luke? Layla?
Yes, I'm.
Good morning. Ashley?
Good morning.
Good morning. Kachira? I know you're here. I'd like to hear your voice. Kachira?
I'm here, Professor.
I knew you were here. I just was waiting to hear you. Jennifer, I know you're here also.
Yes, I'm here.
Rachel? Rachel Seeley? Good morning.
Good morning.
Gloria? Corey? I know you're here.
Here.
Denisha?
I'm here, Professor.
Good morning. And Devana? Devana here? Okay. Let me, again, while I have most of you here, I hope you see the sign. The midterm is going to be a week from Friday, March 26th. It's going to be given during class time. Instead of logging on to Zoom that day, you're going to log on to Blackboard and you're going to do your midterm on Blackboard. if any of you have done the test that I gave you on Blackboard, that's similar to the way it's going to be set up. It's going to be a multiple choice test. I mean, I'll know more about it when I see it in person. I haven't seen it yet, but it'll probably be a 20 question multiple choice test like the one that I gave you on Blackboard. And we're going to be doing some more review today towards the end of the class. After we do a couple more of these type of questions, we'll go and do some review. I plan to start review by 11. And whatever we don't finish by reviewing on today, we'll finish on Thursday. Okay, does anybody want more time to work this one out?
Yes.
Okay. Okay, I think we should get started. Let's again, this is an example that could have been solved using factoring, but I want to use the quadratic formula for this particular example. And in order to do that, I'm going to write down what my A, my B, and my C are. So the A we know is the number that's in front of the x squared. Most of the time there isn't a number in front of that x squared, though sometimes there is. The number in front of that x squared is understood to be 1. So the A is 1, the B is positive 3, and the C is negative 18. And we fit it into our equation formula like we did before. Here's my negative B. So negative into the parentheses goes a 3. Plus or minus. Here's my square root. Make it long because there's a lot of things that go into it. It's B squared. And the B I know I fill in with a 3. Minus 4. And there's an A and a C. The A I know is 1, and the C is negative 18.
Okay, I got lost right after I solved that part.
Okay, let's go through it again. You found this.
Yeah, I did that part. So I had gotten 9 minus 72.
Okay, I'm not up to that yet. I'm just putting in the numbers,
Okay.
okay? And I'm just substituting the numbers. Now I'm gonna write what I get. Okay, so this is a -3. And here's my plus or minus. Now here's where I have to really work. I have to work at this, but these numbers that are inside the radicals. Those 3 squared is 9. And -4 times 1 times -18 is plus 72. Be careful with those signs. Because there's two, you're multiplying a minus times a minus, you're going to be getting a plus. So this works out to be 9 plus 72, which is 81. So it's the square root of 81. This is where you're going to have to be your most careful. It's the most likely place you can make mistakes because it's so easy to mess up those plus and minus signs. And of course, on the bottom, it's 2 times 1, which is 2. And the square root of 81, I think everybody realizes, is the number 9. So here are my two answers. -3 plus 9 divided by 2 will give you one answer. We will use the plus. The second answer will use the minus, -3 minus 9 divided by 2. And now I simplify. Now when I'm doing this, I first have to combine the -3 plus the 9, which gives me 6. And then I divide it by 2. So 6 divided by 2 gives me 3 as one answer. And -3 minus 9 gives me -12. And when I divide that by 2, notice I combine what's on top first, and then I divide it by the bottom. That gives me -6. So I think it was Cheryl who gave me those two answers, 3 and -6.
Yes, I did.
Yes, thank you. Perfect. Did anybody else get those answers from the formula?
No, because I got stuck. That's why.
Okay, do you see it now?
Yeah.
I actually messed up. And
Okay.
the crazy thing is,
Where did you mess up? That's what I want to know.
oh no, I used the wrong numbers as well. Like I put negative for C, I had -10. I forgot that it was changed to
you forgot
18.
to bring it over.
Yeah.
Okay, so let's go through it again. You can't use the formula until it equals 0. So that's the first thing. You have to have it in descending order equal to 0. And then you write out your A, your B, and your C. If you notice, this could have been factored to a +6 and a -3, and you would have gotten the same answers. Could have gotten the same, you would have gotten the exact same answers factoring. Okay, I want to do one more thing. I think we've got the quadratic equations. Really, what we're doing now, that's sort of the end of what's going to be on the midterm, which doesn't mean I'm not going to start with new material. I am, because it's very important for us to not get behind just because there's a test coming up. I'm going to do one thing that I think will be helpful for you in some of the things we've been doing that actually is a topic that's in the next chapter we're going to be talking about. The next chapter, chapter 5, is called rational expressions. Now the word rational comes from the word ratio, which means fractions. So basically, if you're going to ask me what is our next question, my next question my next questions will have to be about fractions. how to deal with fractions, how to add, subtract, multiply, divide, use fractions in equations. We sort of haven't done any of that yet. And what I want to do is just touch on the topic by talking about how to handle an equation that has fractions in it. Now, I think most people, when they think of fractions, especially adding or subtracting fractions, they say, look, I can't do that. I have to find a common denominator. Multiplying fractions isn't so bad because you just multiply the tops together, you multiply the bottoms together, and you reduce it. That's doable. But when it comes to adding and subtracting, that's more of a difficult topic. But we're going to go through all this very carefully. I'm going to go through it using regular fractions and then using what we call rational expressions, which are just fractions that have letters in them, not just numbers. So that's what we're aiming for. And I'm going to do things a little bit out of order, where I'm going to teach you what to do when you have an equation that has a fraction in it. Because one of the things you can do when you have an equation with a fraction is work it in such a way that you end up with no fractions. So let's say I had an equation that looks like this. What if I were to have given you an equation that I wanted you to solve, and there are fractions in it? Here's what we can do. First of all, make everything into a fraction. It's very hard to work with mixes. This is a fraction, this is a fraction, this is not a fraction. It gets very complicated when you have a mixture of non-fractions and fractions. But any number that's not a fraction actually could be written as a fraction by putting it over 1. So that's the first step I'm going to go. When I see an equation that has fractions in it, and some of the numbers are fractions and some are not, just put those things that are not fractions over 1. So at least you know all the things, you know what's going to be your numerators, the numbers on top. You're going to know the denominators, the numbers on the bottom. Excuse me, I just have to take this call. Hi. Hi, I'm in the middle of teaching, but thanks. Yes. Bye-bye. Okay, the next thing that you do is you find something called the common denominator. It's called the LCD. The L stands for least, C is common denominator. And it actually doesn't even have to be the least. It just has to be a common denominator. And what a common denominator is a number that every single denominator will divide into evenly. Now, if I look at these denominators, the 2, the 5, and the 1, a number that they all divide into happens to be 10. If you have no other way of doing it, you could just multiply the denominators together. 2 times 5 is 10, times 1 is 10. In this case, our least common denominator is 10. Look at, if you have one denominator being 4 and one denominator being 8, then your common denominator is 8. Remember, the least common denominator is always the biggest number because they all have to divide into it. It's not, 2 divides into 10, it goes 5. 5 divides into 10, it goes 2. 1 divides into 10, it goes 10. Each number, when you divide it into that denominator, that LCD, it will give you a whole number. And here's what you do. You take that LCD and you put it over 1, and then you multiply the whole equation by that LCD. Now, I'm going to write every single step totally out. Some people can think some of these steps in their head, but I'm writing it totally out. Notice, since I'm multiplying the whole equation, both sides of the equation, by the same thing, I'm changing my equation, but I'm not changing the final answer. I am going to be getting a new equation that's going to be a lot easier to deal with than this original equation. Now, since I'm multiplying by this 10 over 1, I have to use the distributive property. So I'm going to be multiplying the 10 over 1 times x over 2 equals the 10 over 1 times x over 5 plus the 10 over 1 times 9 over 1. What we did is we distributed this common denominator, this 10 over 1. And the reason I put it, didn't just multiply by 10, but 10 over 1 is because since everything here is fractions, I want this to be a fraction as well. Now, I want you to notice, if I multiply this first thing, remember, the way you do multiplication is you multiply the tops together. So 10 times x is 10x. And 1 times 2 is 2. And the 10 and the 2 could reduce. So 10x over 2 just gives me 5x. Because I multiplied by the common denominator, each one of these are going to come out to be a number without any denominator. It's 10 over 2 is 5. You don't even have to write it 5x over 1. You could just write it 5x. Actually, we could have even done that quicker. When you're multiplying fractions, you can do something that's called cross cancel. You can divide a numerator and a denominator. If I had done that, just go through this. You'll see I'll get the same result. Any numerator and any denominator can be canceled out. I can divide this 10 by 2 and get 5, and the 2 by 2 and give me 1. So then I will get 5 times x over 1, which is obviously just 5x. So doing this cross canceling actually makes, you don't have to do it that way, but it makes it a little bit quicker. Let's go on to the next one. Here I have 10 over 1 times x over 5. Again, I can cross cancel. I can cancel out The 10 I can divide by 5 and get 2. And the 5 divided by 5 and I get 1. And in that case, I get 2x over 1, which is just 2x. And finally, over here, nothing cancels out, so I just multiply across. 10 times 9 is 90 over 1 times 1, which is 1. Since all of these things were over 1, I didn't have to put in there 1. And look what's happened. I took this equation that had a bunch of fractions in it, and just by multiplying by the common denominator, it gave me an equation that has no denominators, an equation that has no fractions. And then I can just solve this by regular solving, subtract 2x from both sides. Which will give me, going over here, 3x, because 5x minus 2x is 3x, equals 90. And then I just have to divide by the 3. And that gives me x equals 30. So this is a method of solving an equation that has fractions in it by doing, yes, this takes a little bit of time, this multiplication, but after I've done the multiplying by the common denominator, I end up with an equation that has no denominators, no fractions, and it's just much easier to solve. I want to do another total one with you together, and then I'm going to give you one to try. And by then it'll be time to do some review for the midterm. I hope I'm not erasing this too soon, am I?
Yeah,
Okay, I'm sorry. I'll leave the other one, the next one
it's
on.
okay. The last part.
Okay, I'm leaving on this part.
Yeah, you can go ahead and read.
Okay.
Thank you.
I'll try. I have to remember not to do that. I have to give more time. Where is? I'm sorry, I'm just looking at specific problems that I want to go through. And I don't know where I put those questions. Got it. Okay, you know what? We're going to do an example that is a review example, but it's an example that we did without fractions. And this question is going to have fractions, but it's also in the way of review, so we'll get both things accomplished. In chapter 2, we pretty much reviewed chapter 1. Chapter 2 is a chapter in which we talk about graphing of linear equations. And a lot of the questions that are asked on the midterm in general in that chapter have to do with writing the equation of a line. I'm going to review that, and I'm also going to review before the end of the day how to, the systems of equations, at least one or two problems. Okay, but let's look at this problem. We want to write the equation of the line through the point 2, 4. We want to, and parallel to y equals -4/9x plus 1. Okay, so we're reviewing how to write equations of lines that are either parallel or perpendicular, and they're going through a point. After we do this one, we're going to go back and do the same exact problem, except we're going to do it using using perpendicular lines. Okay, so let's review what we know about parallel lines. What do we know about parallel lines? Anybody?
That they run alongside and they don't intersect.
Yeah, and what do we know about their slopes?
That the slope stays the same.
Right, they both have to have, because they're slanted the same exact amount, because they, as Corey said, they run right side by side, their slopes are exactly the same. So I'm going to write an equation in the line y equals mx plus b of this line that's parallel to this line. And then since it's parallel, I know that the slope of the line that I want to write the equation of has to be exactly the same as the slope of the line that I started out with. And what is that slope?
-4/9.
Right. So my equation, I'm starting out with y equals -4/9x plus b. What would the slope have been if they said perpendicular?
It would have been reciprocal.
What would the numbers be?
9 and 4.
It would be positive, and it would have been positive because it's what we call the negative or opposite reciprocal. It would have had to be positive 9/4. So using these terms parallel and perpendicular, right away tell us information about the slope. But we don't have any information about the b. We have to figure out the b of this line as well. And that's where this comes in. The point 2, 4 being on the line means that when I put in the x for 2 and the y for 4, it'll fit into the equation. It'll make the equation correct. So I'm fitting it in. Remember, over here, this is the 4 because that's the y equals -4/9 times x, which we know is 2, plus b. And here happens to be an example like we were doing before, where we have fractions. And let's see how we could do this with this new method that I talked about of getting rid of the fractions by multiplying by the common denominator. So before I do that, I have to take any whole number and put it over 1. So the 4 has to go over 1, the 2 has to go over the 1, and the b has to go over the 1. And then I compare all the denominators, 1 and 9. What's my common denominator? Anybody? What would the common denominator be? 9. Because again, you could just try multiplying them. I'm going to take this 9 and put it over 1 and multiply it by the whole equation. Most of the time, finding the common denominator is not particularly difficult. You take that number and put it over 1. And then what you're going to do is you're going to distribute. You're going to do 9 over 1 times 4 over 1 equals 9 over 1 times negative 4 over 9 times 2 over 1. This is a little complicated because you have you have 3 things that you're multiplying, but it's fine. It's not going to be hard. And then it's going to be the 9 over 1 times the b over 1. Again, you put this 9 next to each term. Now you don't put it next to both of these because these are attached by a times. You just put them next to this one and this one that are connected by pluses or minuses.
Professor,
Yes.
how do we know when to use this operation?
I would say use it anytime you run into fractions. If you see your equation has fractions in them, then do this because I think this is the easier way to get rid of the fractions. Does that answer your question? If there are no fractions in your equation, you don't have to do this. But if you see that you're ending up with something like 4 over 9 that you're going to have to deal with, then you can use this method of getting rid of the fractions. Does that make sense to you? Was it Kashira that I was talking to?
Yeah.
Is that okay with you?
I'm just confused because wait, never mind. It's fine.
Okay, you see, I looked at this thing and I saw all this 4 over 9. You know, like if I had a fraction like a half, I might not do it. But when I have a complicated fraction in my example, I want to sort of
Professor,
get rid of it. Yes.
do we have to use this method? Because I feel like when we was doing parallel and solving from mx plus b, how we were doing it before is so much simpler. Now this is just so complicated.
Okay. You know what? Should I chuck this and do it the way we did it before?
Yeah.
Okay. I think you're going to see why I wanted to do this. Can I erase this midterm? Everybody know when the midterm is. Okay.
You said it's the 26th, right?
It's the 26th. That's a week from Friday.
Okay,
Okay.
thank you.
So now I'm going back to this. We have 4. I'm going back to what we had over here. 4 equals negative 4 over 9 times 2 plus b. You want me to do it the old way, right? Okay, what's my first thing that I'm going to have to do? I'm going to have to multiply this 4 over 9. Now, I better put this over 1. That'll give me negative 8 over 9, correct? Because negative 4 times 2 is negative 8. 9 times 1 is 9. So this is 4 equals negative 8 over 9 plus b. What should I do next? What do I have to do next?
Subtract negative a over 9. Add negative a over 9 on both sides.
Okay. Perfect. Because she wants to get the b alone. How do you add 4 and 8 over 9? That's the question. How does one add? This didn't come out to be a nice number. Anybody remember how to add fractions? Okay. One thing you can do Most of your calculators have fraction buttons. You could use your calculator. Unfortunately, I can't teach you the calculator because everybody has different calculators, and if I don't have it in hand with you next to me, it's very hard for me to teach it to you. See if you can figure out how to do this.
In the calculator, do we have to divide 8 divided by 9 and then we add 4 to get our answer?
But then you're going to get a crazy decimal.
So what is your way into using the calculator for fractions?
Okay, that's what I'm saying. And the problem is that I don't know which calculator you have. What I would ask you to do, if you would like to, take a picture or maybe even send me, sometimes there's a link of your calculator. And if I will see your calculator, I will be able to explain to you how to do it. And I can't give you general instructions because every single calculator works differently. So here's what I'm going to show you. You see the problem here. Do you see the problem here? I'm going to show you what we could use, that new method that I talked about. We have this. Until now, all the examples we did, this number didn't turn out to be a fraction. It turned out to be, yeah, that sounds right. As a matter of fact, 44 over 9. So, Corey, you know how to use your calculator. See, it pays for you to try and figure it out. But let me show you what we could do. We could do what I was telling you before. Put this over 1 and put this over 1. And you see your common denominator is 9. Multiply everything by 9 over 1. Now look what's going to happen if I do that. I'll get 9 over 1 times 4 over 1, which will give me 36 over 1, which is just 36, equal 9 over 1 times negative 8 over 9. And look at these 9s will cancel out. This will cancel out with this. And that'll just leave me negative 8. And finally, it'll be plus 9 over 1 times b over 1, which is just 9b. Multiplying everything by the 9, think about it. This had nothing on the bottom. It was just a 1, so that gave me 36. This had a 9 on the denominator, so it just canceled. It gave me the negative 8. And the b had a 1 on the bottom, so I just did 9b. Now add 8 to both sides, which will give you 44 equals 9b. And then your b is 44 over 9. Which is what Corey got by just using his calculator. Did you like that better? Was that more understandable? Was it like a combination? Because if you don't know how to add the 4 and the 8/9, you could do it. You don't have to do that. You could just multiply everything by the denominator, and then you will get the right answer in the end. Anybody, any questions, any comments? Okay, so now we can go back and write what the equation is. The equation then turned out to be y equals negative 4 over 9x plus 44 over 9. What makes this difficult, and I know this is what the problem is, the fractions. The fractions cause this to be a more difficult problem, but there are questions that are going to have fractions in them, and we just have to be willing to try and deal with the fractions. Okay. I'm going to give you the same problem. Instead of, it's through the same point. Instead of being parallel, I want it to be perpendicular. And I'm going to give you a few minutes to try that. I want you to write the equation of the line that goes to the point 2 comma 4 and is perpendicular to the line y equals negative 4 over 9x plus 1. I'm leaving this on the board for a few minutes for you to try, for you to have it in front of you. Okay, I think we should try this. Again, we want to write the equation of a line, so it's y equals mx plus b that we're looking for. Remember, we always try to find out what the slope of the line is going to be first. What do we know about the slope of my line if it's going to be perpendicular to y equals negative 4 over 9x plus 1? What is my slope going to be equal to? Anybody? I know Zia has a
9 over 4.
right. The slope now has to be positive 9 over 4. Since it's perpendicular, you have to flip this over and switch its sign. So my equation is going to be y equals 9 over 4x. This is the m plus b. And now we're going to substitute the point that they gave me. The y they said is 4, the x is 2. So this becomes 4 equals 9 over 4 times 2 plus b. And again, we have this fraction that we have to deal with. Well, remember what we said, when we're multiplying fractions, we multiply the numerators together and the denominators together. So that's going to give us 4. 9 times 2 is 18 over 4 times 1, which is 4, plus b. Now, this 18 over 4, I could actually simplify. As a matter of fact, you probably could even change it to a decimal, but you could, let's leave it as a fraction. 18 over 4 is the same as 9 over 2. I'm just dividing top and bottom by 2. Okay. And like we did before, we have to bring this 9 over 2 over to the other side. So the question is, how do I do the 4 minus the 9 over 2? And one way of doing it is just change 4 to denominator 2. 4 over 1 is the same as 8 over 2. So I get 8 over 2 minus 9 over 2, which is negative 1/2. Again, if you put it into your calculator, Corey, did you put it into your calculator?
Not yet.
Okay. If you did, if you put in 4 minus 9 over 2 in your calculator, it'll give you, it might give you negative 0.5 also, which is acceptable. So your answer for your equation becomes y equals 9 over 4x minus 1/2. In other words, in this case, sometimes the b comes out to be a fraction. This was not as difficult a fraction as the one before. Again, in my method, you could have multiplied everything over here by 2. Let me just show you how my method would have worked. I'm going up here. Where you have, over here, we could have done 4 over 1 equals 9 over 2 plus b over 1. I'm starting right over here with, after I reduce this 18 over 4 to 9 over 2, and by putting the whole numbers over 1 and multiplying everything by 2 over 1, because my common denominator is 2. So the 2 times the 4 gives me the 8. The 2 times the, this will give me 9 over 2, which is just 9, right? The 2's cancel, plus 2 times b, which is 2b. And if I bring the 9 to the other side, this will give me negative 1 equals 2b. And again, we get the b equaling negative 1/2. Somehow, you can try, again, I would love you to be able to do the fractions on your calculators, but I don't know how to, unless you send me your particular, a picture of your particular class, and again, and if you has shown me, and if you have shown me or sent me a picture of your calculator, I should be able to use your particular calculator from about usually 9:20, certainly 9:30. Anybody wants to come on to the Zoom early. Okay, I hope you can you hear me now?
Yes.
Okay, good. Okay, so I'm gonna go, let me see if I can find see if I can pin myself. Okay. Let me just do at least one example of a system of equations of the type that you might see on the midterm. Questions that you have to know how to do. They're not quite as difficult as the ones that I gave you as an optional on the Delta Math. But let's say I gave you a question that sounds like this. Suppose somebody was selling tickets to a concert and he sold 400 tickets. He sold a total of 400 tickets to this concert. And there were two types of tickets that he was selling. He was selling adult tickets for $4 each. And he was selling children's tickets for $3 each. And when he counted up all his money from all the tickets that he sold, he had a total of $1,500. From all the 400 tickets that he sold, he made $1,500. And we want to try and find out how many adult tickets he sold and how many children tickets he sold. Basically, this is the type of question you should be able to answer by setting up a systems of equations. Either it'll be tickets or it could be a product. It could be somebody sold 400 t-shirts. Some were red and some were blue. Or somebody sold peanuts and Cracker Jacks. And you know how many he sold and you know the price of each, and you want to know how many he sold of each kind. That type of question. So we do this by setting up a system of equations. Does anybody want to tell me what they think I should do first? What do I have to do first?
Can we say that adults is X and children's Y?
Perfect.
So 4X plus 3Y equals 1,500.
Okay. So the first thing she did is she did what we call, she set up what her variables are going to be. Her variables, she said, the number of adult tickets, she's going to call X. And the number of children's tickets, she's going to call Y. In other words, we call it making a legend. Set up what your variable represents. You can't write an equation unless you know what you're writing an equation about. Now, one equation that she suggested we write is that 4x plus 3y will equal 1,500. And she's absolutely correct, because 4 is the price of each adult tickets. So if let's say there are 100 adult tickets, 4 times 100, she'd make $400 on that. So you take the price of each ticket multiply it by the x, which is how many there are. Do the same thing with the 3 and the y, and that'll give you the total amount of money that you've gotten. Is that all I need? How many equations do I really need?
Two.
Okay, but I only have one. What's my other equation? Anybody have a suggestion as to another equation? Okay.
X plus y
Natalie,
equals 40.
Natalie also came out with that. We didn't use the fact that there were a total of 400 tickets sold. That has nothing to do with how much each ticket costs, it's just how many there are. So your other equation is x plus y equals 400. Zia said it, Natalie said it, perfect. Okay, now what we have to do is solve this system of equations. And we have to decide if we're gonna do that to either get rid of the x's or the y's. What should I get rid of? What should I eliminate, the x or the y?
We can eliminate the x.
Okay, let's eliminate the x, which means that the bottom equation I'm going to have to multiply by the 4. And the top equation I'm going to have to multiply by the 1 because I use their opposite coefficients. And then I have to decide, do I have to use a minus or not?
Yeah, you need a minus so they could cancel out.
Right, so which one should I make the minus? Does it make a difference?
No.
So what do you want me to do, Kashira?
The first one.
Okay. It's totally up to you. You'll get the right answer whichever way you do it. Okay, so our top equation becomes negative 4x minus 3y equals negative 1500. And our bottom equation becomes 4x plus 4y equals 4 times 400, which is 1600. And now when I add them, the negative 4x and the 4x cancel out, which is what we planned. We planned to eliminate the x. Now we have a negative 3y and a plus 4y, which is a plus 1y or just y. And a negative 1500 plus a 1600 gives me a positive 100. Look, if my answer comes out to be negative or it comes out to be a fraction or anything like that, you know that you're doing something wrong. But this came out to be 100 adult children's tickets because Y stands for children's tickets. So how many adult tickets are there? Well, we can go to this equation, which is so simple. X plus, now I know the Y is 100, equals 400. And if I subtract the 100, it'll give me that X equals 300. So there were 300 adult tickets sold. Be very careful not to mix up your adult with your children's. That's why, again, it's so important to decide and write down what your variable stands for. If you get X equals 300 and you forget that the X you chose was the adults, you could say there's 300 children's tickets and you would have done everything right except gotten the wrong answer. Okay, it is now, I think, time for class to be over, basically. Does anybody have any questions they want to ask me before the end of class? There are some, there is an assignment on Delta Math on quadratic equations that should be available today. Don't forget to do the test on Blackboard if you haven't done it yet. You can do it again. If you did it and you didn't like your mark, you can do it again. Just tell me and I'll reset it. Also, if you see there are things that you don't like, you didn't know, you can ask me those questions in the next class. Yeah, Jonathan, you had something you wanted to ask me?
Oh yeah, I sent you an email this morning. I didn't know if you had class prior to ours, so I just wanted to let you know that I sent you an email this morning
I
in
didn't
regards to my
see,
grade.
I'm gonna look at your email and then if you, again, anytime you want to talk to me one-on-one, you can certainly do it before class. Or if you want
Okay,
to, any other time, you could just let me know.
thank you. I appreciate it.
Okay? We okay? Any other questions? Melissa, you're doing class now?
Any situation
Yeah.
that y'all been through, right, in life, and how y'all got through it, and how y'all are here right now.
Okay,
If
so,
anybody is ready.
okay, so there's, and, I think, did you take a look at the, at the test on Blackboard?
No, I didn't get a chance to look at the
Okay,
test.
so that's something you might do before the next class, so if there, you'll see what kind of questions there are on it.
That's a practice test or the test that they did?
That's, no, the test that they did, which is a practice test, but it's really, it is a test. But you can,
Okay.
look, like, I don't mind if you help them with the doing, I wouldn't do the exact questions, but you could help them with the types of questions. Okay? All right, everybody, I'll see you on Thursday. Have a good day.
Thank you.
Bye-bye.